as you're kind of finishing up, I'm going to start talking since we got less time today. Um, Basically, what we're going to do today is we're going to factor some of these polynomials. Factoring can kind of be a pain in the butt sometimes. The way we're going to factor today, we're going to mostly use graphs, so it's not like the worst kind of factoring. Sometimes, like I said, factoring can be a pain, but most of what we're doing today is not as horrible as normal factoring, I think. Those two theorems, I think, are kind of confusing, if you ask me. So like for a polynomial p of x minus c is a factor of p of x. That was kind of that same x minus c that we used the other day for like our remainder thing. If and only if that p of c is equal to 0, and then that other one kind of leads into that. And I think what that other one is trying to do, that factor, solution, intercept, whatever, equivalence theorem, I think it's just trying to like walk you through steps there. I think those 1 through 5 things are like steps to show you like, how that x minus c relates to the other stuff. Basically what's happening on those steps there is that x minus c is the factor. So like you're going to have something like this for your answers today where it's going to be like factored out. So each of these little chunks of like numbers there, x minus whatever your number is for those are like the factors. And then what they're showing there, walking through those like 5 steps, is basically you want these factors to all equal 0. And then if you're trying to get those factors to equal 0, they end up all being x-intercepts of graphs. So conveniently what we can do is we can just graph these and look for the x-intercepts, and that helps us come up with our equations. Okay, so most of your answers, if it says like, hey, come up with a factored polynomial or whatever, are going to look something like this. This k number out front here, that is just some constant. So that's just some constant. That just means it's just some number there. Sometimes we'll know that number, sometimes we will not. Sometimes we can figure it out, sometimes we can't. If you can't figure it out, you just kind of leave it as nothing there. But pending what they give us, sometimes we can't find it, and I'll show you that. So there's going to be 2 different versions of these equations that they kind of give you here. One is going to be in standard form. Standard form is where it's like all the way like expanded out, and it's not going to have any of like the parentheses in it, kind of like our standard form the other day where we go like highest power down. Important thing to note on the standard form, if it's in this form, whatever this back number is that does not have an x value in it, that is always your y-intercept. So I would add that little note there. And this graph here is actually the graph of those equations. So you can see here from that graph, so that's at like 50 and that's at 0. Right there, that spot where it's crossing would be 30. And that will always be true when you've got it in that expanded form. Whichever one doesn't have the x, once it's all solved out there, is always the y-intercept. Okay? And then that factored form, what that helps us with, again, that 2 out front is just basically, it's kind of just determining like how tall or how short each of those little curves are. It's just what those numbers are. It's just kind of determining the size. These factored versions here are going to tell us where it's crossing this x-intercept here. So like here, it says we've got like x plus 5. Well, with this factoring stuff, you want each of those chunks to equal 0. So the number that would go in there for x that would kick out a 0 for that group would be a -5. So that's why one of our things is -5. And you can see here that that's crossing at -5. And that would be one of our 0 values we're looking for. Okay, similar with the other one there, you got x minus 1 and x minus 3. Well, if you put a 1 in there and a 3 in there, that would make those chunks equal to 0. So our other crossing spots there are 1 and 3, and again, those are our 0 values that are going to be helpful for us. Okay, so the zeros are always just where it crosses that line. Factored form is us taking those values and putting them in those parentheses groups. Okay, and I'll kind of show you that with the examples. So grab your packets out, and we got 3 examples we'll look at. So the first one here, they've got it in that standard form, and they want us to factor it. Like I said, there's different ways to factor, but the easiest way for what we're doing is to graph this. So what I'm going to start by doing is I'm going to graph that equation there. So I guess it's a function actually, but either way. So we're going to graph that to start. Go zoom standard to get it back to just something a little better. Obviously it's going to be kind of a crazy graph here. So I got something kind of like this to start, where it's just kind of a bunch of lines, but we know it's probably got those curves and stuff in it. An important thing to note here is if this back number is 120, the one without the x, that means that that's our y-intercept. So we know if this is kind of what we're starting with, like a 10 by 10, we know that our y is going to have to at least go up to 120. And then based on that, probably this part of the graph's probably going to be in the hundreds as well, in the negative area. So if I just go to my window, my x's are fine. That seems to be showing me all the stuff. But I'm going to change my x and y minimums to like negative 150 and positive 150 because I know my intercept's got to be 120. So I'm going to try that. And there I get a little bit better version of what my graph would be, right? So what I'm going to do is I'm going to sketch this out here. I didn't need that so big. I'm just going to kind of sketch that. And W business out. And then, like I said, important things to note here. We know that that value is our y-intercept. So it would be crossing there at 120. And the other important things to us are our zeros, okay? So our zeros here, we can either, so these ones end up being nice numbers, so we can get them from the table. You can also do like second trace and then go down to 0 and find those as well. Like I said, these ones are nice from the table, so I'm actually going to go to my table here. And you're just scrolling through to figure out where your y's are 0. So basically this spot, this spot, this spot, and this spot. So you can see we got a couple in the negatives there, so I'm going to see if I can try to find those. So it looks like I got one there at -5. So, and I'm getting this because on my table here, at -5 it's 0, and at -3 it's 0. So that guy would be at -3. Keep scrolling there. Looks like I got another one at 2 and 0. So that guy would be at 2. And then my other one there's at 4. Like I said, if they're nice numbers, you can get them from the table. If you're looking through your thing and you can't find any of them on their table, they're probably decimal numbers, so then you can just go second trace and find your zeros that way. That'll work as well, and you can do that this way too, but they're nice numbers. So then what that does for us is when we come up with our little equation here, or function actually, so p of x is equal to, all of these values here are all part of our like little factored thing. So you're going to have, since there's 4 intercepts here, you're going to have 4 little groups. Each of them's just going to have an x in it. And then like here, because this is crossing at -5, what you want to do is you always want it to, basically you want this to kick out a 0. So if I put in a +5 in there, so like x plus 5, if I took that -5 and put that in there, wouldn't -5 plus 5 be 0? Yeah, so it's always going to be opposite sign when you put it in. So like if that's a -3, it would be x plus 3. Because if I put a -3 in there, -3 plus 3 would be 0. Then with these two, they're going to both be minus. So x minus 2 and x minus 4, because if you put those in there, each of those chunks would be 0. And how that works is, I think we talked about this a little bit, if I made this whole thing 0, does it matter what the rest of those numbers are? Because if I take 0 times anything, isn't that always 0? Yeah, so if you can make one of those equal to 0, they'll all be 0, so that's why you can have it like that. Okay, it's, like I said, it's a little bit confusing, but the main thing is find those crossing spots, those turn into your parentheses groups. And then from there, it wants us to find all of the values for which it's 0. Those are just the numbers that it kicks out there, those zeros. So you just list those numbers out. So like -5, -3, 2, and 4. And that's all you would have to do on something like that. Okay, let's try another one here. So with this next one, they actually tell us what our y-intercepts are, so we don't have a graph of it. We're supposed to come up with whatever. So it says our our x-intercepts here are, well, it says it's a degree of 3, which just means there's 3 of them. They're -8, 12, and 13. So if we did have a little graph of this, they're saying, if we had like our little curve shape or whatever in there, they're saying that we'd have a crossing spot at -8, crossing spot at 12, and a crossing spot at 13. That is a horrible graph and not even remotely proportional, but something like that. So now when we set this up, what we want to think here is similar to what we had before, so something like p of x is equal to, in this case we can actually find our number out front, and I'll show you how to do that in a second, so I'm just going to leave that as like an a right now. It's just kind of like a placeholder. And then here, if our zeros are at the -8, the 12, and the 13, here if it's -8, that would mean it's +8 in my equation. X plus 8 there. Next one would be minus, so it's a positive 12, so x minus 12. And then the back one is also positive, so it would be x minus 13. And then If they didn't give us this y-intercept, we would stop at this point because we wouldn't have enough information to find this a. Because they do give us that y-intercept, we do actually have enough information to find that a value. What the a value determines is like how big this graph is. So like here we know it's going to go through those spots, but what we don't know is like how big it is going through those spots, because those would be different, types of equations. That's what that a number determines, is like how tall it is. What we can do to find that is we can use this y-intercept value, because it's telling us our graph there is crossing at negative 624. So what we can do is we can use that to do some solving out. So here, if this is our y-intercept, the ordered pair of that would be 0 for the x, negative 624 for the y. So what you can do is you can take that information, put it into this equation, and then it'll kick out like our a value. So here what I'm going to do is I'm going to think of, if it was p of 0, that it would kick out a 620 or negative 624. So then what I can do is I can put zeros in for all of those x's, and then I know it's supposed to kick out this negative 600 number. So I'm going to go negative 624. It's equal to, again, that a is what I'm trying to find. And in all of the x spots, again, because this is crossing at 0 there, I can put a 0 in for all of those x's. So like 0 plus 8, 0 minus 12, 0 minus 13. And then luckily that's easy math there, right? Because it would just be whatever those numbers are. So like 0 and 8, 8, 0 minus 12, negative 12, 0 minus 13, negative 13. Then you just treat that as an equation. So like you would multiply those guys out. It's a decent sized number. It's 1,248 when you multiply those guys out. And then again, just treating it like an equation. Well, to get rid of multiply by that number, divide by that number. And it actually comes out to be an even negative a half. And what that negative a half is that value that would go up in there for the a. Okay, and we can only figure that out because we have that y-intercept. Sometimes we won't have that, sometimes we will, but we could do that there. So here our final answer would be p of x is equal to, again, that a of negative a half is going to go in that spot. And then we'll just have that factored out stuff, the x plus 8, x minus 12, that kind of crooked there, x minus 13. And that would be our final one factored out. Again, that's kind of confusing. A lot of this stuff is a little bit tricky. Okay, let's attack the last one then. Okay, so the last one here, again, they give us all of our 0 values. So those are our ones we're going to put in our little parentheses groups for our factors. In this case, they don't give us what the y-intercept is, so we don't have to worry about that front a number or whatever. It's just a possible equation for this. That's why they'll sometimes say give a possible equation or something like that, because depending what that a is. But here we'd set it up similar, so they don't give us, oh yeah, they do, g of x. So g of x is equal to, again, each of these are going to be our zeros, so we'll have 3 parentheses groups there. And we know that because it's a degree of 3, and there's 3 values there. So negative 4 would end up being x plus 4, because it's always opposite sign. The 1 would be x minus 1. And then with this fraction here, it would be x minus 4 over 7. But having that there as a fraction is not a good form of this. So what you want to do instead is you want to make it so you can still have it kick out a 0 when that fraction's in there, but not have a fraction in your answer. So these first ones are going to stay the same. So g of x is equal to x plus 4 in a parentheses, x minus 1 in a parentheses. And what this one actually looks like is it's going to end up being 7x minus 4 for its little thing out. How that works is, again, each of those little chunks is supposed to equal 0. If I put that 4 over 7 into this chunk, so like 7 times 4 over 7 minus 4, what ends up happening there is if this is fractions, wouldn't those 7's cancel each other out and have 4 minus 4? And isn't 4 minus 4 0? Yeah, so that's how that works. So whatever your bottom number is, that just gets multiplied out front. Whatever the top number is, that's just added or subtracted at the back. Okay, so if you have a fraction one like that, that's the way you want to do it. Instead of having it as a fraction, that's just not good form. Okay, like I said, I know that's a little bit confusing, but that's kind of the general gist. Basically finding those zeros, putting them into those little parentheses groups. Okay, and if we need to talk more about it before we take the test and stuff, we can. Deal? Okay. So that's your book page there. Give that a shot. I should be, unless something crazy happens, we got snow or whatever, I should be here